Hey guys, this is a video on the types of energy we used in and talk about in physics. These are the types we're going to calculate, and I'll introduce all the formulas to you in this video. So, first type of energy is kinetic energy. If something is moving, it has kinetic energy. So kinetic energy is the energy of motion. All right. By moving, we mean it has a velocity. So if there is a V, as you can see in the kinetic energy formula, then you could calculate kinetic energy based on that velocity. The formula for kinetic energy is 1/2 times mass times velocity squared. It's only the velocity that is squared. All right? Mass has to be plugged in kilograms, and velocity has to be plugged in meters per second. All right? Our second type of energy is called gravitational potential energy. So potential energy means it's stored energy. When something is lifted up to a certain height, it gets gravitational potential energy. If you let it go, then that gravitational potential energy will turn back into kinetic energy, energy of motion. So gravitational potential energy is just energy stored due to height. Here's a little diagram on the side. Draw that to say that the height is always equal to 0 at the object's lowest point. And then when you lift it up, it gets height and it gets GPE. The formula for GPE is mass times gravity times height. Remember, gravity is 9.8 meters per second squared. Alright, and you've got mass and height in the formula too. Alright. Our third type of energy is elastic potential energy. Alright. That's energy that can be stored not by lifting an object, but it's energy due to a compressed or stretched spring. Alright. So if you a bow and arrow is a good example of elastic potential energy, or a slingshot. EPE has a formula 1/2 kx squared, right? And what is the k and the x? The x is the distance that the spring is stretched or compressed. Only the x is squared in that formula. It has to be plugged in meters. So however far you stretch or compress that, that's the spring, that's x. K is how stiff the spring is, and it's a unit of newtons per meter. Alright? K is the stiffness constant of a spring. It tells you how stiff it is. So a higher K means a higher stiffness, and a lower K means a lower stiffness.